All right, so here we are with our first lesson, 1.1, exploring periodic data. Now, this is sort of an introductory lesson that's going to come up later in the course. So it is important to learn some of these features of periodic data while we're still early in the class. So a periodic function, any function that repeats a pattern of y values at regular intervals. A cycle is a complete pattern. A period is a horizontal length of one cycle. Amplitude is the half the difference between the maximum and minimum values of the function. So if I use the graph here to demonstrate each of those, the amplitude of this graph, okay, would be the distance from the midline of the function. So the midline is this dashed line. So it's the distance from the midline to the max, okay? All right, or the distance from the midline to the min, okay? That's called the amplitude. All right. The one cycle would be defined as how long it takes the graph to start repeating itself. So let's just say I started here at the origin. All right, the first time the graph starts to repeat, okay, would be here. So I would call that one cycle. All right, which is also considered one period. All right, in this case, it's 6 units. Okay. All right, so let's take a look at a couple examples here. Identifying cycles and periods. For each function, identify one cycle in 2 different ways, then determine the period of the function. So if I look at this first one here, it appears as though the graph starts repeating itself every 4 units. So here is one cycle. Okay, and if I identify a second cycle, it would look like this. Okay, so that's 2 complete cycles. All right, so the period of this particular graph, all right, is 4 units. Okay, let's slide to the next one. Again, it's all about identifying that single cycle. So here it looks like maximum to maximum, right? So there the graph starts repeating itself. All right, so there's one cycle. If I identify a second cycle, it would be from here to here. Okay, and it appears as though each of those cycles has a period of 3 units. All right, let's go to the next one. All right, let's determine if the function is periodic. Does it repeat its y values over time? In this case, no, because y value is -1, y value is 0, y value is 1, y value is 2, so forth. So not periodic. Okay, whereas this one here does repeat its y values. So we see here a y value of 2, another y value of 2. We can also identify the -1 minimum, -1, -1. So we realize that they do repeat, and then I determine that the period would be how long it takes to repeat. And in this case, that would be 4 units. Okay. So finding amplitude of a periodic function, let's find the amplitude. So first we have to figure out the midline. So when you figure out the midline of one of these functions that repeats like this, we want to find the maximum, which is 1, the minimum, which is -2, and then determine the halfway point between 1 and -2. So that's 3 units. So 1.5 here, so that's 0.5 below. Okay, which means that my amplitude is going to be 1.5. All right, will be my distance between the midline, okay, and the max or the min. Part B, the midline here, again, if I take those, max and that min, I determine that this one's at 4 and this one's at 2, or -2, excuse me, that's a difference of 6. So that means halfway between them would be 3. Okay, that would be here for my midline. Okay, which means that my amplitude is 3. Okay. Just a sketch of a graph like this. Sound waves are produced by periodic changes in air pressure. Sketch the graph of a sound wave with a period of 0.0004 seconds and an amplitude of 2. Okay, so that means the distance from my midline to my max and so forth is going to be 2. Okay, so let's see here. So if I start here, all right, and I end at 0.0004, okay, then that means I would have a maximum at 2 and a minimum at -2. So my curve would look something like this. Okay, and I could continue that obviously as much as I'd like to. All right, same idea here. Okay, one cycle of a sound wave occurs from 0.002 seconds to 0.008 seconds. So obviously my x-axis is scaled here. So I'm looking at 0.002 as the start, 0.008 as the finish. So halfway between 2 and 8, okay, would be 0.005. Then it also tells me that the maximum value is 4 and the minimum value is -4. So halfway between these 2 points, okay, would be +4. Halfway between these two would be -4. So that's what my curve ends up looking like. Okay, that's the nice thing about periodic functions is when they repeat over time, they form a pattern. A lot easier to work with those patterns. Okay, so putting it all together here, let's talk about each of these. A periodic function goes through 5 complete cycles in 4 minutes. What is the period? All right, so 5 cycles every 4 minutes. That's nothing more than a rate. Okay, so if I were to, there's 2 ways I could look at that. I could do 5 cycles per 4 minutes, or I could determine how many cycles per minute, right? So that'd be 4/5 cycles per minute. All right. And again, if I really wanted to break that down into seconds, then I would want to realize that there's 60 seconds in 1 minute. So I would take 4/5 times 60, and I would determine that there's 48, okay, seconds for 1 cycle. Okay, any of those would be acceptable answers. Period of a function here is 8 seconds. How many cycles does it go through in 30 seconds? Okay, so if 30 seconds is how long it's been happening for, and each cycle is 8 seconds, then I would take 30 divided by 8. I would figure out that it was 3.75 complete cycles in that amount of time. Or I have one like this here where the amplitude of a function is 2.5 and the minimum is 0. What is the function's maximum? So if I think about what that graph looks like, okay, and I know that the minimum value is 0, which would be on the x-axis, and I know the amplitude is 2.5, so that would be the distance from the midline, okay, to the minimum. It should be the same distance from the midline to the maximum. So 2.5, okay, and 2.5 would give me a max at 5. All right, so from here, you just want to look on your practice example or your practice problems for 1.1.